Welcome here in this session about safety masterclass with some Schneider products. My name is Miklos Bakos. I'm the offer manager of Schneider Electric. I'm a marketing guy, so I'm not going to do a very deep technical presentation. So I try to make it digestive for you. I brought 3 topics today, all related to safety. The first one is the Lexium MC12 multi-carrier. The second one is embedded safety and what we mean under embedded safety with Schneider. And the third one is Cobot and the safety-related things with Cobots. So let's get started. What is the multi-carrier system? I hope that the audience knows it very well. If you don't, it's a tracking system with linear motion. So there are different independent moving carriers around the tracking system. You can utilize it for really a very wide range of different machines. It's really opened the door for many opportunities. So that's the first video. Let me show another one. It's one of the features I like the most. This is a flush, anti-flush technology built in. So if you have a normal conveyor, you can see the water level moving like this. If you're moving a multi-carrier like this one, built-in flush, you can see that even without the cap, you can move the bottles. So that's one feature. Of course, a very wide range of features, but today I want to only discuss the safety. So how this multi-carrier system builds, the main components. So there are, of course, the straight segments, and there are curved segments. On the top of the segments, we connect the segments with the signal bridges, and at the bottom with the power bridges. These 2 parts will be very important for the safety things. Of course, there are some guides and the carriers itself, independently movement. So, if you use these bridges at the top of the track system, and when you cut the line, by the way, the safety line is also included in this. So when you cut the line, you can, and this is the point. Can you see? Yeah, you can see this laser one. So if you cut this line here and here, you can get 2 independent safety circles. So zone 1 and zone 2. You can dedicate one safety relay to the zone 1, another safety relay to the zone 2. In this way, you can only stop one zone, and the rest of the zone, if there are several zones, all the operation can be move on. So let me give you some example. When there is a manual operation station during the conveyor, or when there is an operator needs to change the cartridge, or when there is a blockage in the conveyor, you don't need to stop the whole conveyor system. You only stop one zone. You do the maintenance or do the replacing process, and after the whole system can be run. Of course, if this pause is just a couple of minutes, the carriers will, go to the edge of the other safety zone and waiting for to move on. So if it's just a couple of minutes, the performance there is no issue. So the output in terms of how many packages, how many products was handled, it will be the same. So that's the first thing. With safety zone, you can improve this productivity. The second one is the embedded safety. If you remember, the very basic setup with the servo drive is you have 2 cables. One cable for the encoder, another cable for the power. There is a technology when you can move on to the single cable solution. With the single cable solution, you put these 2 signals and the power into one cable. So we have a hybrid cable solution when we put really everything in one cable. So it means the power, the communication, and the safety, even at 24-volt DC, put in one cable. So you can see here, you have a drive Anyway, it's not a drive, it's just a power supply, but let's call it now a drive. Distribution box and the drive itself, the motor itself. So you can see here again in this fight as well. With this solution, just to understand, to be very clear, you have, for example, a picker line with Delta robots. Let's say 5 different Delta robots in a row. How many cables you need? If there are 2 cables per axis, 4 axes per robot, so it's 20, 40 cables altogether. With this solution, you only need 1 single cable between the cabinet and the robots. And we're moving from the cabinet to the robot, 1 single line, including all the signals and the power as well. And at the top of the robot, when we start building the robot line, we're using these distribution boxes and distribute it to the robots, and after every robot, the axis. So it's a very, very straightforward and a nice solution. So the embedded safety part is that we have the safety circuits-free safety communication as well, and it's also included. So again, 1 single cable and these included. With this one, based on the example what I said, it was 40 cables to 1 cable. So it's roughly like, I would say, here it's put in the slide, that 70% or even more saving can be in the cabling. So you can save the cables, the cost of the cables, of course, cost of the installation as well. By the way, this thing is based on integrated drives. So the servo motor is not a servo motor, it's an integrated motor, which means that the power electronic is mounted inside the motor. So if you're looking at the normal servo drive, you have the rectifier part and after the power electronics. So we remove the power electronics and move it to the motor. So in the cable, in this hybrid cable, we only have a DC power. So we're sending the DC power, supplying the DC power to every motor, and the power electronics will do the job. Okay, so it's an integrated solution. In this way, we don't have drives in the cabinet. We only have the power supply, a dedicated special power supply. So in this way, we don't have big cabinets because all the drives are missing. So with these, you can decrease the cabinet size. Again, it's another improvement. And because the heat is coming from the power electronic and is mounted out of the cabinet, you don't have this heat in the cabinet. So also there is another saving. Of course, embedded safety. So you have the safe torque off as built in, but you have other safe motion related safety techniques as well, such as the safety limited safety operating speed, category 1, category 2 safe stop, so also available. And of course, due to the 1 single cable and the communication, the PLC can get all the variables, safety variables from the safety circle. I would say, or you asked if there is any question, but we discussed that because of the timing, the question should be covered after the session at the Schneider stand. The Schneider stand is at the 124, so 124. So if you have any questions, there are technical guys as well, so you can come and we can discuss further if you have any questions about this solution. And the third topic, before I start about the Lexium Cobots, by the way, Schneider Electric also have their own Cobot, the green Cobot available for a year or so. And let me start with a personal story. As I mentioned, I'm a marketing guy, so I'm responsible to showcase these new products and robots to a wider audience. So we created our first demo machine with a built-in Cobot, and after, most probably you know that at Schneider, the health and safety is very, very high in terms of the priority. So to get the approval internally, we have to move the robot and get the approval from the local health and safety inside their company. And first time it was rejected, to be honest. And that was when we really started thinking about that, okay, the cobot is for collaborating with humans. So why we need, guards and all these technical things, safety things, to get a cobot and work with the humans together? Well, it's not as easy as I thought. So I want to share, 4 different options what the standard defines. Do you know the standard of the cobots is the ISO 15066? It's not mandatory, it's a guide, but it defines 4 different collaboration space solutions. The first one here in this slide is the safety-related monitoring stop. Let's move to this diagram. In this white range, these 2 columns, you can see the robot movements, and in the blue ones below, the operator's movements. It's very simple. If the robot is outside of the collaboration space, even if the operator is outside or inside, movement are allowed. If we're moving to the next one, if the robot is inside the collaboration space, of course, when it's outside the operator, it's fine. But if the operator is also inside, that's what we need to eliminate. This is the area when the protective stop comes in. So there is no operation in this box. And there is a third line when the cobot, the robot, inside the safety in the safety-related monitoring stop status, and in this case we can allow even inside or outside the operator. So there's 2 main stops defined based on the standard or this guide: the monitoring stop and the protective stop. Of course, monitoring stop, the power is still remains on the drive. First, we need to put the drive, the cobot, into this state, the monitoring stop state, and after all the actions inside the collaborating space is allowed. So that's very basic, the first one. The second one, from my marketing terminology, what I use collaboration, this is closer to the real collaboration, the hand-guided operation. So what is happening? The cobot is moving to the monitored stop status, and after with this enabling switch, you can move the object and the robot and guide it by your hand. But you need 2 things. The cobot needs to be in a monitor stop status, and you need a sort of enabling switch that the system knows that yes, there is a human catching the robot. So that's closer to the real collaborative operation. It's a unique application only for this. The third one, the speed and separation. This is usually what we can see in the industry. So usually, cobot environment, palletizing, any other applications, there is a laser scanner. When the laser scanner detects that someone is approaching the cobot, the collaboration space, we just put it in a lower speed, and when they even getting closer, you stop the cobot. So really not a real collaborative operation, but that's what the industry usually widely use. And the number 4, that would be the real collaboration. However, this is the most difficult to reach. This is the power and force limiting. You can see here there is 2 different issues. One is the static quasi and the dynamic forces. Of course, dynamic can be a little bit higher to be allowed. But this is all about that what is the limit which can be painful for the human. There are different studies for this. Of course, different region of the body has a different level, different threshold. And you need to maintain that the speed and the force of the cobot is always below this threshold. So where is the issue? The issue is with the sensitive body areas, the head, the throat, and the neck. And unfortunately, it's not enough just to say and put a sign that do not bend over or keep away, because that's not the right safety process. So with these, even with these areas, cannot be harmful. Sorry, not harmful, it's painful. So the standard, the threshold is very low. So when you start sensing that the robot is touching you, for example, and you is moving to the level when it's getting painful. So it's very far from the harmful level, but it's a painful level. So that's the real collaboration mode, based on my understanding as a marketing guy. And but that's the most difficult. So these 4 different operation modes are utilized in a mix. So in the industry, usually some mix of these can be utilized and seen. Thank you.